anomalous behavior of the second period elements. See, the second period elements from group 1 to group 17 I am talking about. It's lithium, beryllium, boron, carbon, nitrogen, oxygen and fluorine. So what we find is all of these elements shows anomalous behavior. The first thing before going into the details of this, you need to know both the S and P block elements are called representative elements, because the first element of the groups of the S and P block, they represent the whole of their groups in their property. That's why whole of the S and P block elements are called representative elements. But what we find is that the first element of all these S and P block groups, they show very much different behavior or anomalous behavior. Like the behavior of these 7 elements is very different, which are belonging to group 2, and this is 13th, 14th, 15th, 16th and 17th. The reason of the anomalous behavior is very small atomic size, especially with reference to the other group members. Second is high nuclear charge. As a result, that's why what they have is they have very high ionization enthalpies. It becomes very difficult to take out electron from these elements. Their atomic volumes are very small, very less, because of their very small size. Their ionization energies are very high. Their electron gain enthalpies are very high, and some more reasons can be penned down. The electronegativities of these elements are very high. So these are the ones which we have already seen that it plays a very important role in determining the physical and the chemical properties of the elements. The other most important difference is that they are deficient of d orbitals. They don't have any d orbital, because second period or the second orbit doesn't have the d suborbits. They have only 2s and 2p. Whereas the elements which are actually coming after or from third period onward elements, what we find is they all have a d orbitals. Now what the difference all these properties makes in the behavior is that what we find is they all become what very small in size. They all becomes what highly it becomes very difficult to take out electrons from them. What we find is their melting points are very different from the rest of the elements. Their behaviors are very different. We know all these are the only 3 ones which forms hydrogen bondings because of their very small sizes. So all these kind of differences we notice in their properties. Another difference, they cannot extend their octet because they have only what 2s and 2p suborbits. So they can accommodate only what 4 pairs, 8 electron. So they cannot extend their octet. The maximum covalency they can show is 4, like they can form like compounds BF4 minus. Whereas the elements of the other periods, they can easily extend their octet because they can have D, so D can accommodate 5 pair, and S can accommodate 1 and P can accommodate 3. That makes them to ability to what go up to what 9 pair of electrons. That's why what we find is like in case of aluminium can form up to what 6 bonds. So what we find is it can easily extend its octet. So these are the behavior changes where we find. Another change, they doesn't have much higher tendency to form complexes, and if they form, that doesn't goes beyond 4. whereas the elements of the other periods, they can easily form complexes, and that usually are beyond 4. They are not up to the covalency of 4 because they can extend their octet. Another difference which we find between these elements and the rest of the elements is that due to small size, specifically I'm talking about these 5 elements, they can form pi bonds. They have a tendency to form pi bonds. Like we know carbon-carbon bond, oxygen-oxygen bond, nitrogen-nitrogen bond. So they have a tendency to form pi bonds. That's why what we find is that they are the only ones which can form pi bonds with their same type of atoms or with their other smaller atoms. And that is why their behaviors are found to be very different from the rest of the elements.